In this tutorial we will explore arrays and slices. So like most languages, Go has arrays. While you often use slices, it's important to understand arrays because Slice uses them under the hood and they have their own use cases. An array is a sequence of elements that share the same type. They are fixed in size, meaning the length of the array is defined when you create it and it cannot be changed. Let's start by looking at some ways how we can declare an array. Var 0 array, and I will explain in a moment why we call it that. And then we have to give it a size. We will give it a size of 5 and it will be an int array. This will create an array with a length of 5. Because we did not specify any values, Go will set all elements to 0 values, which is 0 for ints. If we had done the same for string, the elements in the array would have been empty strings. If you already know what values you want in your array, you can specify it like this. So var myArray, give it a size. Let's set this one to 3 and let's give it some values. So 5, 10, 15. If we don't want to set all the values, we can choose to specify at what index we want to set them. So it would look something like this. Var cars, and we give it a size, let's say 5, and that would be a string array. So at index 1, we can say Volvo. Index 4, we can set like BMW. We can also replace the number that specifies the size of the array with 3 dots. It will then determine the length of the array based on the number of elements provided. Var snacks, and here we're not going to specify a number, we just write 3 dots and string chips, popcorn, peanuts. Let's print out all the values of the arrays we created. So fmt print line 0 array, and then my array cars and snacks. So open up a terminal and then we can run go run main.go. So for the first result, we only get zeros. And in the next array, we can see we have 5, 10, 15, and it's printed here. For the cars arrays, we can see here we have 1 empty string, and here is 2 empty string. And at position 1, we have Volvo, and at position 4, we have BMW. And for the snacks array, it's just print chips, popcorn, peanuts. But we specify the size with the 3 dots. We can also get a length of an array, and to do that we can use the len function. So fmt print line and then len, and then we just pass the array. So in this case snacks. Let's open a terminal and run it. Go run main.go, and as we can see here it printed out 3. Let's see how we can compare 2 arrays. So we will create 2 new arrays. So let's call the first one for x and then set it equal to, give it a size of 3, and it's supposed to be an int array. And then let's say 1, 2, 3, and then we can create a second array, y. Let's update the name of it, y. And let's add a print statement here, fnt print line x equal y, fmt print line x not equal y, and let's see what result we get. Go run main.go, and we get true and false. Arrays will be equal if they have the same length, contain the same elements, and are in the same order. as we can see they do here. To update elements in an array, we can use the following syntax. So x, and then brackets, and then we specify the index we want to update. Let's say we want to update the first element. So we say 0, and then set it equal to 10. And we try to print that out, fmt print line x. And we can also print out that element, so fmt print line x square brackets 0. Let's run that. So in the first print statement we get 10 because that's the value we set it to, and we can see the array is now updated to be 10, 2 and 3. If you would try to read an index that does not exist, go with then panic and you would get an error. So let's say we would read index number 4, which doesn't exist. It's already going to say invalid argument, index 4 out of bounds. So if you know the length ahead of time, you can use arrays. However, if you don't know the length, it would be better to use slices. And that's what we're going to cover now. Slices can change in size, allowing you to add or remove elements. Operations like append, copy, and slicing subsets are common with slices, providing a versatile tool for managing collections of data. Let's start by declaring a slice. Let's call it some slice. And I can set it to, so we had brackets, and then 5, 10, 15. As you can see, it looks very similar to arrays, but the difference is we don't specify a size here. Same as with arrays, you can specify what indexes you want to set. Var cars slice, set that to be a type of string, and index 1 Volvo, index 4 will be BMW. And when we set a slice without giving it any value, it will be nil. Var slice with no value. In Go, nil is used to represent something that doesn't have any value assigned to it yet. Let's see how the arrays looks like when we print them out. fmt print line, some slice, and then car slice, slice with no value. Open up a terminal again, go run main.go. So 5, 10, 15. And then we can see here, so empty string, first index is Volvo, and then 2 empty strings, and the fourth index is BMW. The last array is empty because we didn't give it any value. We can't compare slices like we did with arrays. You can only compare a slice with nil. To check if a slice is nil, you can write equal nil. And we get true back. And that's because if you don't give a value to a slice, it will be null. If you want to check if 2 slices are equal, you cannot do like this. You have to use the equal function. Let's see how that works. We will start by declaring 2 new slices. Say fruits 1, we set that to a string slice. String apple, banana, peach. And then let's create a second slice. We will call that one fruits 2. If we try to compare them like we did with arrays, we will get an error. So fmt print line fruits 1 equal fruits 2. And it will then say invalid operations. Slice can only be compared to nil. So how do we then check if 2 slices are equal? Go has an equal function. So you can write slices dot equal, and then we can pass fruits 1 and fruits 2. And we get true back. And let's change this. For example, strawberry. And we run it again, and then we get false. And you can also only use the equal function on slices that are of the same type. So if this was a int slice, then it would not be possible to compare these two. And same as with arrays, we can also check the length of a slice. We do that by using the len method. So fmt print line, len slice with no value. Then let's fmt print line, len fruits1. And this one we can delete for now. Because slice with no value is a nil slice, we will get back 0 in length, and for fruits1 we will get back 3. To add values to a slice, we can use the append function. So for example, fruits1, and we set that equal to append, and then you have to pass the slice you want to append to. So in this case, fruits1, and then the elements you want to append. Let's append coconut. This function doesn't modify the original slice. Instead, it returns a new slice that includes the added values. So if we print this out, fmt print line fruits1, and we can see here that coconut has been added to the slice. It's also possible to append multiple values at a time. So let's use the append function here again. Instead of appending coconut, let's append strawberry, raspberry, and we now see here coconut has been added, and so has strawberry and raspberry. And we can also append a slice to another slice. So let's create a new slice, and we can set that to be a string slice with the value of durian, dragon fruit. To append the values of another slice, we can use the ellipsis operator. So it works like this. We do same as before, fruits1, and set it equal to append. Pass fruits1. We write fruits 3, and then we use 3 dots. This will unpack all the elements in fruits 3 and pass them as arguments to the append function. Let's see the result of this. And as we can see, durian and dragon fruit has been added to the fruits1 slice. In the background, slices are using arrays. Every slice has a capacity property. That's how many elements the slice can hold before it have to resize. When a slice needs to resize, it will create a larger array and transfer all the old elements to it. Let's see this in action and how it works. We can start by defining a slice. Let's call it nums. We set it to be of int type. fmt print line, then we pass nums. We also want to print the length of it, so len nums. And then to check the capacity of the slice, we can use the cap function. So cap and pass it nums. If we run this. So this is the default when you declare a slice without giving it any value. It will have a length of 0 and also a capacity of 0. So if we try to add some elements, nums equal append nums pass 1. And after that we can print it again. And let's do this a few times so we can see how the capacity changes. So here we append 2, 3, and 4. And let's append one more time, 5. So here we can see how the capacity grows. And for smaller slices, fewer than 1024 elements, every time the capacity is reached, it will be doubled. So first 0, 1, 2, 4. And here is we still didn't go over the capacity, but here we go over the capacity. The length is 5, and we can see it doubles. For larger slices, the capacity will increase with 25% every time the limit is reached. To summarize it, every time we add an element and we exceed the capacity, Go will increase it. For smaller slices, it will double it, and for larger slices, it will increase it with about 25%. If you know the capacity you need for a slice, you can use the make function to set it up front. This helps optimize your code, and it looks like this. Let's create a new slice, nums2, and set that equal to make, and we want it to be int slice, and we pass the length, give it a length of 0, but we give it a capacity of 20. If we now append to the nums2, so nums2 equals append, and we pass some values 5, 10, 15, and 20. And we can print this out. So fmt print line nums2 length nums2 and then cap nums2. So we can see the length is 4, the capacity is 20. If we would not have used the make function here, Go would have to do a resizing and create a new array and copy over all the elements. But because we set a capacity of 20, there is no resizing that needs to be done until we reach this limit. To get a subset of a slice, you can use something called slicing. Let's create a new slice, nums3, and we make it equal to an int slice, int, and then let's say 2, 4, 8, 16, and 32. Now let's say we want to get a new slice containing only 4, 8, and 16. fmt print line, and then nums3. Here is how the slicing syntax will look like. So you open brackets, and then you specify the starting position. So let's say 1, and the end position 4. The start position includes the element, meaning index 1 will be included, in this case 4. But for the end position, the index is not included, it's up to. So 0, 1, 2, 3, 4, meaning 32 will not be included in the result. So we run it, go run main.go. And as we can see here, we get 4, 8, and 16. Also, you don't need to specify the start index or the end index. Both of them are optional. Let's see how that looks like. fmt print line and nums. And let's say we want to skip the start position. Brackets, colon, and we write nothing to the left here. And then let's say 4. So if you leave out the start index, it will start from the first element in the array. And let's see how it looks like if we leave out the end index. Let's start from nums3, and then let's start from index 1, and then we leave out the end index. So if we leave out the end index, it will extend to the last element. And then one last thing we can do is we can leave out both the start and the end index. nums3, and then we just do this, brackets, and then colon. And if we run this, this is from the first print statement, 4, 8, 16. And this one, when we leave out the start index, we can see here it starts from 2 and then 4, 8 and go up to, because we specified index 4. And if we leave out the end index, you can see here we start from index 1, so that is 4, and then it will include all the elements after that, 8, 16, 32. In the last example, when we leave out start and end index, the whole slice will be printed. And slicing can also be used on arrays, it's not only for slices. One thing to be aware of when using slices, it will not create a copy of the elements, it will still use the same reference. So let's create a new slice, and nums4, and we set that equal to be a slice of nums3, so nums3, and then let's say index 1 as start position and index 4 as end position. And then let's modify nums4, so nums4, and let's give index 0 a new value, so let's say 1337, and let's print out the result. So fmt print line nums3, fmt print line nums4. As we can see here, both of the slices has been modified, and that's because they use the same array under the hood. Now that you have seen how slicing works, I will show you how to remove an element from a slice, because there is no built-in function for removing elements. This must be done manually. So here is how that would work. Let's create a new slice, call it S. We set it to an int slice, int 10, 20, 30, 40. And let's say now we want to remove 30 from the slice. So we can do that by using S equals append, and then we pass a slice of all the elements before the item that should be deleted. So s brackets and then colon. We leave out starting position and then we write 2. So it will take these elements. And then we will pass all the elements after the one that should be deleted. So we can do that by writing s. So 2 plus 1. And then we leave out the end index. And then we have to use the ellipsis operator to pass all the arguments. 3 dots. And let's print it. Print line. Yes. And we can now see from the result that 30 has been removed. And let's say we want to remove the first element, 10. Then we could just write 0 and 0 plus 1 here. And we should now get back 20, 30, and 40. And you might be wondering, how do you actually copy a slice without using the same reference? And Go has a built-in copy function for that. So let's see how it works. Values, we set that equal to 5, 6, 7, 8. And then we create a new variable. We call it new values. And we set that equal to, here we will use the make function. So we create an int slice. We want it to have the length 4. We can use the copy function here. Copy. And then we pass the destination. So new values. And we pass the slice we want to copy from. Values. Then we can try to modify the first element in new values. So new values. Index 0 equal to 13, 37. If we now print out the slices. So fnt, print line, new values. fnt, print line, values. We can see here only new values is modified and not the values array. That means they are not sharing the same reference. So choosing between arrays and slices depends on your needs. Arrays are simple and fast for fixed size collections, while slice offers flexibility for dynamic data. With this tutorial, you should now have a deeper understanding how to use them. Thank you so much for watching and see you in the next tutorial.